perform Young's double-slit experiment on a whole new level, tracing its precise path either through the right slit or the left slit.
The universe doesn't care what you believe about reality. Right now, as you watch this video, particles of light are behaving in ways that would make Einstein himself question everything he thought he knew about existence. There's an experiment so simple a high school student can perform it, yet so mind-bending that it suggests our entire understanding of what's real might be completely wrong. The double-slit experiment reveals that the very act of observing something changes its fundamental nature. Matter exists in multiple places at once until you look at it. Reality itself seems to be nothing more than an illusion that only becomes solid when someone's watching. But here's what will really mess with your head. This is happening right now, all around you, with every photon of light hitting your eyes. The screen you're staring at, the room you're sitting in, even your own body, none of it might be as real as you think. If you're fascinated by the mysteries of space and the universe, make sure to hit that subscribe button and ring the notification bell. We're about to explore the experiment that broke reality itself. Scientists have been trying to explain this phenomenon for over 200 years and they're still failing. The story begins in 1801 with a British scientist named Thomas Young. He wasn't trying to revolutionize physics or question the nature of existence. He just wanted to settle a simple debate about light. Was light made of particles like tiny bullets flying through space? Or was it a wave like ripples spreading across a pond? Young's setup was brilliantly simple. He took a light source and aimed it at a barrier with two parallel slits cut into it. Behind that barrier, he placed a screen to see where the light would hit. If light was made of particles, you'd expect to see two bright strips on the screen, one behind each slit. That's not what happened. Instead, Young saw something that should have been impossible. The screen showed alternating bands of light and dark, an interference pattern. This pattern could only be created if light was behaving like a wave, passing through both slits simultaneously and interfering with itself. The bright bands appeared where the wave peaks lined up and reinforced each other. The dark bands formed where peaks met troughs and canceled each other out. This discovery changed everything. It proved that light was a wave, not a stream of particles. For over a century, scientists were satisfied with this explanation. Light was a wave in the electromagnetic field, just like James Maxwell had described. Case closed, but the universe had other plans. In the early 1900s, Albert Einstein discovered something that threw a wrench into the whole wave theory. Through his work on the photoelectric effect, he proved that light also behaves like particles, discrete packets of energy called photons. Suddenly, light had a split personality. It was both a wave and a particle, depending on how you looked at it. This created a massive problem. How could something be both a wave and a particle at the same time? Waves spread out over space. Particles exist at specific locations. These properties seem mutually exclusive. Yet experiments kept showing that light displayed both characteristics. Scientists decided to dig deeper. They repeated Young's double-slit experiment, but this time with a twist. Instead of using a bright light source that sent millions of photons at once, they fired single photons one at a time toward the slits. Here's where things get absolutely bizarre. Each individual photon hit the screen at a single specific point, behaving exactly like a particle. But as more and more single photons were fired, something incredible happened. The same interference pattern emerged. Somehow each photon was interfering with itself, as if it had passed through both slits simultaneously. Think about what this means. A single photon, one indivisible packet of light, was acting like it went through both slits at the same time. It was existing in multiple places at once until it hit the screen and had to choose where to land. But the story gets even stranger. Scientists couldn't accept that particles were behaving this way without understanding why. So they decided to spy on the photons. They placed detectors at each slit to see which path each photon actually took. Surely this would solve the mystery once and for all. The results defied all logic. The moment they tried to observe which slit the photon went through, the interference pattern completely disappeared. Instead of the wave-like bands of light and dark, they saw exactly what you'd expect from particles. Two bright strips, one behind each slit. The photons were now behaving like normal particles, each going through one slit or the other. The act of observation had fundamentally changed reality. When no one was watching, the photons behaved like waves, existing in multiple states simultaneously. But the instant someone tried to peek, they snapped back into being ordinary particles with definite locations. It was as if the universe knew it was being watched and changed its behavior accordingly. This phenomenon isn't limited to photons. Scientists have repeated this experiment with electrons, atoms, and even massive molecules containing 60 carbon atoms. Every time the results are the same. Matter itself seems to exist in a ghostly state of possibility until the moment someone observes it. The implications are staggering. If fundamental particles don't have definite properties until they're observed, what does that say about the nature of reality itself? Are we living in a universe that only becomes real when we look at it? Niels Bohr, one of the pioneers of quantum mechanics, proposed what became known as the Copenhagen interpretation. According to this view, particles don't have definite properties until they are measured. Before observation, they exist as waves of pure possibility, mathematical descriptions of all the places they could be and all the states they could occupy. The act of measurement forces these possibilities to collapse into a single, definite reality. It's as if the universe is constantly running all possible scenarios simultaneously, but only commits to one version when forced to by an observer. Einstein hated this idea. He famously declared that God does not play dice with the universe. He believed there had to be hidden variables, some deeper reality that determined the outcomes, even if we couldn't see it. Einstein spent the last decades of his life trying to prove that quantum mechanics was incomplete, that there was a more fundamental theory waiting to be discovered. He never succeeded. Every experiment designed to test Einstein's ideas has confirmed the bizarre predictions of quantum mechanics. Reality really does seem to be fundamentally uncertain until the moment of observation. But what counts as an observation? Does it require a conscious human observer? Or is any interaction with a measuring device enough? This question has sparked decades of debate and led to some mind-bending interpretations. Some scientists propose that consciousness itself plays a fundamental role in creating reality. In this view, the universe exists in a state of quantum superposition until a conscious mind observes it and forces it to choose a specific outcome. Others suggest we're living in a multiverse where every possible outcome actually occurs, but in separate, parallel realities. When you observe a quantum event, you're not forcing reality to choose. You're simply finding out which branch of the multiverse you happen to be in. The many worlds interpretation proposes that every quantum measurement splits the universe into multiple copies. In one copy, the photon went through the left slit. In another, it went through the right slit. Both realities exist, but we can only experience one of them. Recent experiments have pushed the boundaries even further. In 2023, researchers at Imperial College London created a temporal version of the double-slit experiment. Instead of slits in space, they created slits in time using ultra-fast laser pulses. The results showed the same interference patterns, suggesting that time itself might be subject to quantum uncertainty. MIT physicists have performed what they call the most idealized version of the double-slit experiment to date. They used individual atoms as slits and fired single photons at them. By adjusting the quantum states of the atoms, they could control how much information was available about the photon's path. The more information they gathered, the more the wave-like interference pattern faded away. This confirmed Einstein was wrong about his specific predictions, but it also revealed something profound about the relationship between information and reality. The double-slit experiment forces us to confront uncomfortable truths about the nature of existence. The solid, predictable world we experience every day might be nothing more than an emergent property of countless quantum interactions. At the deepest level, reality might be far stranger and more uncertain than our everyday experience suggests. Some physicists compare our universe to a video game. Just like a game only renders the parts of the world the player is looking at, reality might only become definite when it's being observed. This saves the universe from having to maintain every possible state simultaneously, a kind of cosmic optimization. The experiment also raises profound questions about the role of consciousness in the universe. If observation is required to collapse quantum possibilities into definite realities, and if consciousness is what enables observation, then conscious beings might be fundamental to the very existence of reality. This isn't just philosophical speculation. These quantum effects have practical applications that affect your daily life. The GPS system in your phone has to account for quantum mechanical effects to maintain its accuracy. Quantum computers, which harness the strange properties of superposition, promise to revolutionize everything from drug discovery to cryptography. The double-slit experiment reveals that reality is far more mysterious than we ever imagined. It suggests that the universe might be more like a probability cloud than a collection of solid objects. It hints that consciousness and reality might be intimately connected in ways we're only beginning to understand. Every time you turn on a light, every photon that hits your retina is carrying this quantum mystery with it. The very act of seeing involves countless quantum measurements that collapse waves of possibility into the definite reality you perceive. The next time you look around your room, remember this. What you're seeing might not be what's really there until the moment you look at it. Reality itself might be nothing more than an elaborate illusion created by the act of observation. The double-slit experiment has been called the only mystery of quantum mechanics by Richard Feynman, one of the greatest physicists of all time. It contains within it all the weirdness and wonder of the quantum world. It challenges our most basic assumptions about what it means for something to exist. But this is just the beginning of the quantum rabbit hole. The implications of these discoveries extend far beyond physics into questions about consciousness, free will, and the very nature of existence itself. If this video has blown your mind, make sure to like it and subscribe to our channel for more mind-bending explorations of space and physics. Leave a comment below telling us what you think about the nature of reality. Are we living in a simulation, or is consciousness fundamental to the universe? And share this video with someone who loves pondering the deepest mysteries of existence. The universe is far stranger than we ever imagined, and we're just getting started on this incredible journey of discovery.